Now see this. We are supposed to solve these equations. We have four equations and four variables are given. Therefore, we got 4 by 4 A matrix. So ax equal to 0. If I write it, then it is 4 by 4 matrix, quotient matrix. Okay. So now again the same thing. I'll try to apply only row transformations and convert it into echelon form. Find the rank of it. That is the entire thing done here. So if you observe this, 1 is already here. So it is better that if I have this 1 at the beginning, so that I can use it and make all the elements as zeros. So for that reason, I'm just exchanging R1 and R4. I'm just exchanging R1 and R4. See, even if you exchange R1 with R4, since it is only a row operation, again you will get back all these equations. That is why you are supposed to apply only row transformations. Again you will get the equations which will be equivalent to this system. If you apply any column transformation, then what happens is you are actually changing the quotients of W with quotients of X or something like that in the same equation. That is not allowed. That should not be allowed, right? Okay, anyway, I think you understood why row transformations are applied. Fine. And now using this element, we are supposed to make all these elements as zeros. For that, I am applying the suitable transformations here, row transformations again. And I got all the elements as zeros. Okay. And next thing is, I want to make using this element, I want to make all these elements, the remaining two elements as zeros. This element is used to make these two as zeros. Okay. So for that reason, what I'll try to do is, I'll try to subtract from R2 this one, so that this one will become 4. Then both of them will be equal. That is one way to do it. Or other way to go about it is, maybe you can subtract add these two and subtract from here and then exchange it. So anyway, these three are related in some sense. I am going in one order. So the order that I am following is from R2, R3 is subtracted and then replaced with R2. Therefore, at R2, I am going to subtract R3 and replace it there. Then I got this. Now, using this element, I want to make these two elements as zeros. So just to make that possible, I can divide it with 4 and then use that 1 to make these elements as zeros, or the other way around. Instead of dividing this one, you can multiply the others. There is no need to multiply this because it is very easy to make it as 0 directly. So just multiply this with 4, then you can multiply this one with 7 and subtract it from that. So for that reason, I am multiplying R3 with 4. Okay. And the next one is multiply this one with 7 and subtract from here and replace it here, so that this one will become 0. And then subtract this one from here and make it as 0. So that is what I did. Now if you observe it here in this one, you are able to find out, it is in echelon form. The number of non-zero rows are nothing but rank of the matrix, which is 3, and in fact you are able to find out a triangular matrix, right? And it is a 3 by 3 matrix whose determinant is not equal to 0. So it is clear that rank equal to 3. In echelon form, the number of non-zero rows equal to 3. By that way you can find out, or you are able to find out a submatrix, a triangular matrix whose determinant is not equal to 0. Then what about the linearly independent solutions? It is again n minus r. Then what is n minus r? 4 minus 3, which is equal to 1. Therefore we have one linearly independent solution. Then what can we do? We can apply random values to one variable and the remaining r variables, right? See, for one variable we can apply random values, and the remaining r variables we have to find them in terms of this random variable, right? So what I'll do is I'll just erase this and again I'll do it there. Okay, see this. So I'm continuing where I left earlier. This is the final transformed quotient matrix that I got. Now I'll be using this final transformed quotient matrix and I'll be solving the equations. So whatever the equations were given, they are now equivalent to this form. So I'm just writing them here. So even though given equations were different, after transformations I got these equations and these equations are equivalent to them. Therefore using them or using these three is same. Now what did we understand earlier? I told you that one of the variable can take a random value and the other variables have to be expressed in terms of this variable. That is what we are going to do. So for that reason, I'll assume that w is going to take random value and the other variables will be expressed in terms of w. So what I am trying to do is I'll be writing all the other variables in terms of w. So see this, z equal to, from this one you can clearly see that z equal to 7 by 9 w, and you take the value of z and you substitute it here. This 7 by 9 w you just substitute it here, then you can find out the value of y in terms of w again. Then I got y equal to 4w. Now you take z value and y value and you substitute it here. Z and y values you substitute here, and again you will get x value in terms of w. This is what I got. As we already decided earlier, that we are going to give arbitrary value to one of the variable. I will be giving arbitrary value to this w. Now the arbitrary value turned out to be c. I mean, just for the sake of constant, I am just putting it as c. Then we get from all these, in place of w's, if you substitute c, then this is what I got. So since c can be any random variable, any random number or any number, we can substitute lots of values for c, and every substitution for c will act as a solution to this given equations, and so these particular equations are going to have infinite number of solutions. See this, here we have only two things, either there is zero solution or there is infinite solutions, but then the number of linearly independent solutions will be 1, which is nothing but this. This is the linearly independent solution. Are you getting this? Now the actual solutions which we can form using this one is infinite. Therefore we can say that there are infinite number of solutions. Got it? Including 0. 0 is always a solution. 0 solution is always a solution in case of linear homogeneous equations. Apart from that, I got one linearly independent solution from which we can derive infinite solutions. Got it? So the answer is, generally what they ask is in GATE, how many solutions does it have? Infinite number of solutions. How many linearly independent solutions does it have? Only one, n minus r. Okay? Or how many variables will be assigned? Random value, some arbitrary value, one variable. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. and then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.